Hello and welcome to this short video presentation of the paper entitled "A Comparison of Structured Light Scanning and Photogrammetry for the Digitisation of Physical Prototypes." The process of generating a 3D representation of a physical prototype is referred to as digitisation, and there are two main reasons that we would want to digitise physical prototypes. First, in product development, designers typically make many design iterations in both physical and digital domains, and they therefore move back and forth from one domain to the other. Creating this digital representation manually can be a lengthy process, and therefore by digitising it automatically, this can greatly expedite transitions between these digital and physical domains. Second, as prototypes are often by their very nature a one-off, it's not uncommon for designers to update and amend existing versions of prototypes as the design process evolves. Whilst working like this enables quick and agile prototyping, a drawback is that previous prototypes can't be reviewed once they've been superseded. By digitising physical prototypes in the process, this can enable increased traceability of the design process and also facilitates designers to revisit previous iterations of designs. A number of techniques exist for digitising physical prototypes, and this study looks at two such methods: structured light scanning and photogrammetry. Structured light scanning involves projecting a pattern of visible light onto the surface of an artifact. When the light hits the artifact's surface, it's distorted by the geometry, and this distortion is captured by a camera, and the captured images are converted into a 3D model. Photogrammetry refers to the process of estimating the surface geometry of an artifact from analysis of 2D images of said artifact. Given the potential affordance of digitisation of physical prototypes, the aim of the study carried out was to assess the performance of these two different digitisation techniques, and this is done both in terms of the accuracy of captures and also the usability of the two different techniques themselves. The method used to assess and compare these two different techniques involved the digitisation of 4 different test artifacts. These were designed such that they each contained a unique set of geometric features, including primitive and freeform shapes. These were arranged such that occultation would occur, which represents a common challenge for many digitisation systems. The full method involved the manufacture of each of these test artifacts via filament deposition modelling on an Ultimaker 3 3D printer. Each artifact was then scanned by a CT scanner in order to generate a master model or ground truth for its as-made geometry. These artifacts were then subsequently digitised via both photogrammetry and structured light scanning, and these were compared with the CT scans in order to determine the accuracy of each digitisation method. This comparison was carried out using Geomagic design software. So how did these two digitisation methods compare? Well, for full comparisons, please have a look at the paper, because obviously there's no time in the video to go through everything. But in a nutshell, structured light scanning had a lower mean error than photogrammetry. Structured light scanning had a higher percentage of measurements within tolerance. Structured light scanning had a lower maximum error than those of photogrammetry. Time per scan for structured light scanning was lower than photogrammetry. And finally, structured light scanning did not require any surface preparation, which was a big factor in decreasing this time. So, whilst there are differences in accuracies, both techniques are able to generate good macro recreation of each part's geometries. In both cases, occlusion is an issue for both photogrammetry and structured light scanning, and this could be mitigated by either using targeted capture with a moving camera or with improved lighting conditions. Structured light scanning was much quicker to use than photogrammetry, and this is due to structured light scanning required much less data cleanup post-scan, and the fact that photogrammetry required patination of surfaces, like in this picture to the right. And in both techniques, user expertise has a significant impact, as it's important to select the correct orientation such that models will align and they can be stitched together when making a 3D model afterwards. So, in terms of conclusions and take-home messages, both digitisation methods are of appropriate quality for consumer goods and are able to digitise repeatably. Structured light scanning achieves a higher accuracy and is quicker to use than photogrammetry, In terms of ease of use, structured light scanning has clear advantages with fewer issues in preparation and data cleanup. Unfortunately, neither of these two techniques can really be considered plug and play, as there is a need to know how to position objects in order to digitise correctly. Thanks very much for listening, and if you have any questions, please do get in touch.